The notes for today on section 10.4 are about factoring trinomials that are in the form x squared plus bx plus c. And so to factor trinomials at Steel Canyon, we introduced this method of factoring to you called t-charting. Now in a t-chart, the numbers on the left must be positive, and you'll see these three circles here. The numbers on the left have to multiply to give you this number in the top. The numbers on the right have to multiply to give you this number on the top. And so with the numbers 5 and 7, there's only one way to get 5 and there's only one way to get 7. Obviously these numbers could go in the other order though, so like if the 7 were on the top and the 1 were on the bottom, it would give you a different answer. But then they have to, when you multiply these ones and when you multiply these ones together, they have to add up to give you the number in the bottom. So we introduce it like a game so that you can practice figuring out what the numbers are. If this number is the number 1 and this is the number 7, 1 times 7 gives you 7, 3 times 2 gives you 6, and then you multiply the ones that are across from each other. So 3 times 7 is 21, 1 times 2 is 2, and 21 plus 2 gives you 23. It's helpful for me to point out on this one though that there's two different ways of getting 6. You can get 6 with 1 and 6, or you can get 6 with 2 and 3. The 3 was already told to you to be the answer for this part right here, so that's how we knew we weren't going to use 1 and 6, but sometimes you have to come up with the numbers on your own. So it's not too bad to think of two numbers that times to give you this number and two numbers that times to give you this number, but sometimes doing the crisscross and add can make it be a little bit trickier. Same on this last one. There's only one way to get a 5, but to get a 36, there's a bunch of different ways you can get a 36. So 36 and 1, 18 and 2, what else gives you? 12 and 3, 9 and 4, 6 and 6. So there's lots of different ways that you can get the number 36, but the only way that you can get 49 in the bottom is 4 times 1 is 4, 5 times 9 is 45, and then 4 plus 45 gives you 49. So it's not necessarily the numbers on the top that you have to be the most careful about. Oh, you have to be careful about them all, but it's the number on the bottom. So we'll go through and do a couple of these together so that you can see my thinking on them. On this one, a couple of the numbers are filled in already. So to get a 3, 3 times 1 would give you 3. And then to get 16, there's a couple different ways that you can get 16. 16 times 1 gives you 16. Let's see, 8 times 2. You can also do 4 times 4. But the 8's typed in for you already here because we're just learning this for the first time, so it's kind of like a hint. If the 8's here, that would mean that the 2 would have to go here, and then let's check it. 2 times 1 is 2, 3 times 8 is 24, and then 2 plus 24 would give you 26. So if there aren't any numbers typed in, that's when you have to be kind of careful thinking about the numbers and how they work. On this one, there's only one way to get 3. It's a negative 3 though, so we'll have to be careful about that. But there are two ways to get the number 4, and so that I think makes it be a little bit tricky. You don't know ahead of time which one of these is going to work, so when you're doing these on your own, I really recommend using pencil. It's a lot of writing it down, checking the crisscross, and then erasing it if it doesn't work out. On this one, it ends up working out with a 4 and a 1, and then over here for the 3, a 1 and a 3. But then, this is what makes it a little bit tricky. This number right here is a negative, which means 1 times 3 would give you positive 3. So one of these has to have a negative on it, but when you add them up across, let's see, 4 times 3 is going to give me 12, and then 1 times 1 is going to give me 1. When I add these up, I'm supposed to get positive 11. That means that I would want the 1 to be negative. Since the numbers over here aren't allowed to be negative, I put the negative on this one right here. So that would be the correct 4 numbers, 4, a negative 1, and then positive 1 and 3 for the t-chart for that number. So sometimes when the numbers are bigger, when they're what we call composite numbers, so like there's two different ways to get 10, and then there's two different ways to get 6. There's lots of mixing and matching that you could possibly have to do. Notice on this one though, the 19's negative at the bottom, and so that means that when you do the crisscross and add it up, you have to get negative 19. In order for two numbers to add up to give you a negative, but multiply to give you a positive, both of these numbers here are going to have to be negative numbers. It can feel really intimidating as a student watching a teacher do this for the first time, because a lot of teachers just show you the right way to do it. When I'm doing this, I try to look at the little numbers I write down here and the little numbers I write down here, the factors of both of these two numbers, and I try to think about how I can get 19. So I'll say 10 times 2 is 20, and then 1 times 3 is 3. But 20 and 3 could give me 17, and it could give me 23, but it can't give me 19. So I know that those numbers don't match up in that particular order. So then I move on and I match up other numbers. 5 times 6 is 30, 2 times 1 is 2, so that can't give me 19. But what happens if I match up the other numbers? 6 and 2 is 12, 5 and 1 is 7, and 12 plus 7 does give me 19. I'll just have to make it be negative 19 when I do it. So I'll put the 5 and the 2 here, and then I wanted the 5 to times by the 1, and I wanted the 6 to times by the 2. So this will give me positive 5, this will give me positive 12. I want them to add up to give me, oh no, that's only going to give me 17. So see, that's a really good example of one where I thought I had the match done correctly, but it didn't end up working out. So when you do that, sometimes you just have to erase and switch these numbers, and sometimes you have to erase and switch all of the numbers. It just depends on the question. So I went ahead and whited those out. It's actually just these two numbers that I have to switch. Because 12 and 5 only gives me 17, and I'm trying to get 19. But if I match up these numbers over here, if I match the 5 up with the 3 to multiply those ones, and then the 2 with the 2, 5 times 3 will give me 15, 2 times 2 will give me 4, 15 and 4 would give me positive 19. Since I want this one to be a positive 6, I need both of these to be negative. And then I would get negative 4 plus negative 15 equals negative 19. 5 times 2 gives me 10, and then negative 2 times negative 3 gives me positive 6. The thing with these is that there's only one way that the numbers can work out right. So in this one, even though I made a mistake that I maybe wasn't intending on making, there's a lot of writing and erasing, and so doing that will help you. We're going to skip letter G and go down here to letter H. See how down here in letter H, these ones have some variables, only in some of the circles though. So to get x squared, and if this is 1x times 1x gives me x to the second power, because when you multiply together variables, you add the exponents. If this is the number 3, well, let's see, there's a couple different ways to get 12. I could do 12 and 1, I could do 6 and 2, or I could do 3 and 4. But if that one's 3, then this one's 4. And so let's see, 4 times x is 4x, 3 times x is 3x, yep, and then 4x plus 3x would give me 7x. So sometimes when you're doing these, there are going to be different combinations of numbers that you have to consider to help you get the answer to the question. So to get 6x squared, I could do 3x and 2x, or I could do 6x and 1x, but on this one they pre-filled the 3x. We did that to help you practice. Let's see. And then if this is a 2, this one would have to be a 3. Let's check and make sure the crisscross works. 3x times 2x would give me 6x, and then that would give me 6x, and so that one would give me 12. And then for the last one over here, let's see. There's 2 ways to get 9, and then there's 2 ways to get a positive 8. So we want to keep all of that in mind when we're doing this question. Let's see. Negative 8 times 1 would give me negative 8. And then over here, I have to decide how am I going to get a 21. With a 9 and an 8, I could get 72, or I could get a 9 and an 8, so that one's not going to help me. So to get 9x squared, I'll do 3x and 3x, and then let's check. This will give me negative 24x when I multiply these together. This will give me positive 3x, and good, that works out, because negative 24x plus 3x gives me negative 21x. The reason why we teach the T-chart game is because we want to be able to factor things that look like this. Remember from last week, when you multiply together two binomials, you do first outside, inside, and last. That's called the FOIL method, and then you combine like terms and you get the answer to the question. So this thing about T-charting is what you would do if you started with this, and if you wanted to go backwards to figure out this. Remember that factoring is the opposite of multiplying. So here, to get x squared, this is a new problem by the way, this isn't the same question. You're trying to figure out what two numbers do you times to get this number in the top, and then over here, you're trying to figure out, so for 6, it'll be 1 and 6 or 3 and 2. Trying to figure out what two numbers do you times together to make a negative 6, so that when you add them up crisscross across, you get positive 1. Well, it could be 6 and 1, but they're not going to subtract to give you 1. So it's going to have to be 3 and 2. This will give you 3x, this will give you 2x. I want to get positive 1 when I add them up, and so that means that I want the 2x to be negative, which means that the 2 has to be negative right here. So the answer for this question would be x plus 3 times x minus 2. That's what you would, how you would t-chart it to get back to your answer. Your answers for these are going to look like the questions looked like before you foiled. So it's kind of like we're going backwards from foiling, because factoring is the opposite of multiplying. Same thing with this one. If I wanted to factor this, and if I didn't have my t-chart set up, what I recommend you do is draw the t-chart, and then I don't actually put circles around them, but this one goes first, the one in the middle goes down in the bottom, and then the last one comes up here on the top. And then you ask yourself the question. So two numbers that times together to give you x squared would be x and x. And then two numbers that times together to give you negative 6. Well, it's either going to be 6 and 1 or 3 and 2. I want them to subtract to give me negative 5. So that would mean the negative would go on the 6 and the positive would go on the 1. Let's check that out. Negative 6x plus 1x gives you negative 5x. And so your answer for this one is x minus 6 in one parentheses, and then x plus 1 in the other parentheses. When you write them down in the parentheses, you always go straight across. So this, even though you multiplied these two together and these two together, when you write them down, this goes into one parentheses, and then this goes into the other parentheses. So this last one I think is the best example, because that's what factoring is going to look like. This is called factoring trinomials by t-charting. For most students, the hardest part is coming up with the numbers that actually work. So on this one, they want me to factor, and so I've got a trinomial. I set up my t-chart. The first one goes first, the one in the middle goes on the bottom, the other one, the last one, goes here on the top. Two numbers that times to give me x squared are x and x. Two numbers that times to give me 6 could be 6 and 1, but I want them to add to give me 5, so that's why I picked 3 and 2. And then remember, you can always check it. 3x plus 2x gives you 5x. This right here, though, is how you write the answer to your question. And so as we go through to do the 3 of these next ones, what you want to be asking yourself on each one is, you might even want to pause the video and see if you can figure out the numbers from the game on the front part of the notes that make it work. X times x gives you back x squared, but there's a couple different ways that you can get 28. You can do 28 and 1, you can do 14 and 2, you could do 7 and 4. I want them to add up to give me negative 11, and so that's how I know that I'm going to need x minus 7 and x minus 4, because negative 7x plus negative 4x would give me negative 11x. If I tried any of the other numbers that times to give me 28, it wouldn't work for this side. Now, one thing you can do to check your answers to these questions, and I want to make sure I point that out here in the notes, is you can always go back and FOIL these and multiply them back out and make sure that after you combine like terms, you get this as your answer. So it's kind of nice because you could check any of your answers. Let's see on the next one. So first, the middle one goes on the bottom, and then the last one goes over here on the right-hand side. X times x gives me back x squared. Now there's a couple of different ways you can get 15. You could do 15 and 1, but those aren't going to be too apart from each other. So I'm going to need my 5 to be negative, and I'm going to need my 3 to be positive. Let's check the across. 3 times x is 3x, negative 5 times x is negative 5x, and 3x and negative 5x would add up to give you negative 2x. If you tried to do this with the negative on the other number, you would get positive 2x down here when you check the across multiplication instead of negative 2x. So that's how you know that the 5 is supposed to be negative, and then the 3 is supposed to be positive. And let's see, on this last one, so again, there's two different ways to get the number 10. And so when you're doing this on your own and not just watching me and listening to me explain it in the notes, remember, getting the x squared isn't bad because x times x gives you x squared, but now you have to decide, do I use 10 and 1? Do I use 5 and 2? Do I use 2 and 5? Does one of them have to be negative? Does both of them have to be negative? So there's a lot that you need to check when you're doing this on your own. In order for these two numbers to add up to give me negative 7, I need to use negative 2 and negative 5. When you write your answers to these questions, it doesn't matter which part of the answer you put first and which part of the answer you put second. So you could flip-flop them, and you could have, like, the x minus 5 could be first and the x minus 2 could be second, and that would be fine, and it would still be a correct answer to the question. So again, this is called factoring by t-charting. On number 3, we're doing the same thing. We're just filling in the blank to make the equation true. So on B, I'll go ahead and I'll factor x squared, 8x, and 15. So x times x is going to give me x squared. And then if you look over here, they gave you a hint kind of, because they already told you that this number on this one was going to be the number 5. So I just have to work backwards and figure out what this number would be. What's the number that I times by 5 to get 15? And so that's how I decide that the missing number would have to be a 3. My answer would be x plus 3 times x plus 5. But the missing number that would go in the blank right here, that would be the number 3. That's the missing number. And on this last one, x squared, negative 11x, positive 24. So x times x gives me back x squared. And then two numbers that times to give me positive 24, but add up to be negative 11, would have to be negative 8 and negative 3. Because negative 8x plus negative 3x would give you negative 11x. So they got x minus 8 already. And so the missing number on this one, the number that would go inside that missing spot, would be the number positive 3. Because they already had the minus sign for me right here. So I'm basically doing the same thing, but they're giving me a hint on what one of the numbers should be, so I kind of just had to come up with the other number. So factoring is a way to go through and unmultiply or unfoil these problems. So when you're thinking really hard about the numbers, especially when you're first learning this, sometimes it can be tricky to come up with the numbers. And again, like I said, it can be really frustrating to watch somebody that's done this a lot do it. Because, like what I did just there where I did the problem and didn't explain it at all, I know that to get a negative 12, they have to be a different sign. So you know one has to be positive and one has to be negative when you multiply them. And I know that for them to add up crisscross to give me negative 1x, I need the bigger of the two numbers to be negative. If I wasn't sure that this was the answer to the question, remember I can go back and I can refoil it out to get the answer to the question. Sometimes when you're doing these, and this can be really frustrating, sometimes they're not factorable. If not factorable with whole number answers, positive or negative numbers, write not factorable. So sometimes when you're doing these for the first time and you're stuck and 36 is intimidating because it's 1 times 36 and it's 2 times 18 and it's 3 times 12 and it's 4 times 9 and it's 6 times 6, and again I recommend writing those down over here. It can be like, not factorable, because it just becomes easier to write it down. That is the answer. But this one is factorable. Positive 12 and negative 3. Positive 12 times negative 3 gives me negative 36. And then 12y and negative 3y add up to give me positive 9y. So I don't want you writing not factorable just because you think the question is tricky. Not factorable means there are no numbers that make it work. Not just that the numbers that make it work are hard for you to think of. Let's try this next one. Remember, at any point today, you can pause the video. Right now would be a good point to pause it to try to think about the numbers on your own. Let's see. 21 is 21 and 1, but 21 is also 7 and 3. And if I want the 4 to be negative, then I would want the 7 to be negative, and I would want the 3 to be positive. So c minus 7 times c plus 3. So this one was also factorable. When you get to D, though, I wanted to make sure to include at least one in the notes today that wasn't factorable. And so let me show you how this one doesn't work. The only two numbers that you can times to give you 5 are positive 1 and positive 5, or negative 1 and negative 5 in either order. But if you plug those numbers in here, like let's say you put in negative 5 and negative 1, negative 5 times x would give you negative 5x, and then negative 1 times x would give you negative 1x, but negative 5 and negative 1 would add up to give you negative 6, not positive 3. If you took the negatives off of them, you could get positive 6, but again, that's not negative 3. So when you write your answer to this question, I would expect on your homework to see a bunch of erasing, and then you would write not factorable. And that just means that we don't have numbers that can make this one work. There's no other way to get 5 that would give you negative 3 when you multiplied across and added those cross products. the last example on the notes for today is intended to help get you ready for what we're going to talk about in 10.5. So sometimes when you're T-charting, you have to GCF or hockey stick out a number first. And so whenever you're doing these problems, you always want to start by looking at them and seeing if there's any number that they, or a variable that they all have in common. So on the first one, I took out the number 12 first, and then I could T-chart what was left over. But notice how on my answer, that number that I GCF'd or I hockey sticked out first, that's still part of my answer. Let's do B together. On B, all three of these numbers can divide by 8. And there's another rule in math that says that when the first one right here is negative, you're always supposed to take out a negative with it. So on this one, I can divide all of the numbers by -8. And then sometimes you can go through, and again, I should have written this down on the last one, but you can go through sometimes, and this thing that you have left over can sometimes still T-chart. So let's see. Two numbers that times to give me -6 that add up to give me -5 would be -6 and +1. You couldn't do -2 and -3 here, because when you would add them up, that would give you -5, but when you multiplied them, that would give you +6, not -6. So here's the thing that everybody always forgets. When you write your answer to the question, you have to put the -8 first, and then it doesn't matter which of these pieces goes first and which of these pieces goes second, because multiplication can flip-flop, it's commutative. But so those give you the two pieces as your answer to the question. On this last one, I can take I have to take out a negative, because the rule says if there's a negative first, I have to take it out. I can also divide all of these by the number 2. And if you look at this one has 4 x's, this one has 3 x's, and this one has 2 x's. So I'm going to GCF or hockey stick out a -2x squared before I start this question. So that's going to leave me with x squared minus 9x minus 10, and then I'm going to check and see if I can still T-chart what's left over. Sometimes you can and sometimes you can't, and on this one you can with a +1 and a -10, because 1x and -10x add up to give you -9x. So when you write your answer to the question, don't forget that you GCF'd this one out first, and then you can put the x plus 1 first, or you could put the x minus 10 first, and that would still give you the correct answer to the question. So you always want to check to see if you can hockey stick or GCF before you T-chart.